All right, you guys, we have a couple more formulas to do here in section 5.4. So you'll notice that what we've done so far for sum and difference was cosine, but we also have formulas for sine and for tangent. And so these are 4 more formulas to be added to the back of your unit circle, but they're going to work the very same way the cosine problems did. It's just a different formula that you have to memorize. So a couple things to point out here about the signs, the way that I remember it. So the addition for sine also has an addition in it, and subtraction has subtraction in it. That's different for the cosine formulas. And for tangent, whatever the sign is of if you're doing a sum, it's a sum in the numerator, and then the denominator switches. So this one is a difference. It's a difference in the numerator, and then the denominator switches. So just a couple of things to point out, and then whether you use sine or cosine or tangent or whatever, you're just going to have to memorize those for those formulas, okay? But this very first problem, this sine of 75, just like we did for cosine, what I'm going to do is I'm going to rewrite this as sine of 30 plus 45. And then I'm going to use the formula up here for addition using 30 and 45 as my A and my B. Okay, so I'm going to use sine of 30, cosine 45, keep the sine, plus cosine 30 times sine 45. And here, again, these are just unit circle problems. So for 30 degrees, remember the sine is 1/2. For 45 degrees, the cosine is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2, and sine of 45 is radical 2 over 2. So just the same way that we did the cosine formulas for these, I'm just going to multiply straight across. This is radical 2 over 4, plus this is radical 6 over 4. And since they have the same denominator, you can write them with the same denominator as one fraction. Radical 2 plus radical 6 over 4. Okay, so the second one is a tangent one, and it's 7 pi over 12. So instead of 7 pi over 12, what I'm going to do is tangent of, I think I'll do 3 pi over 12 and 4 pi over 12, so split those up. Both of those reduce to unit circle problems. So 3 pi over 12 reduces to just pi over 4, and 4 pi over 12 reduces to just pi over 3. So now what I'm going to do is use my tangent formula, which is tangent of pi over 4 plus tangent of pi over 3 divided by 1 minus, and then I multiply the two tangents together. So this is just using the formulas, but you guys are going to have to memorize. Make note cards if you're feeling a little weird about memorizing all these formulas. That might help. And now I just have to simplify this thing. So remember, tangent of pi over 4, that's our 45-degree angle. That's just 1. Tangent of pi over 3, that's my 60-degree angle. That's radical 3. And then I have 1 minus the tangent of pi over 4. I already did that. That was 1. Tangent of pi over 3, I already did that also. That was radical 3. Okay, so 1 times radical 3 doesn't do anything, so that 1 you don't even need. I'll just erase it. And then if you remember back from Algebra 2, this needs to be rationalized, and we use the conjugate to rationalize this. We multiply by 1 plus radical 3 to the top and the bottom. So very similar to using the conjugates when we're verifying trig identities and that kind of thing. The sign for the denominator changes because when you FOIL that out, the radicals will then disappear from the denominator. So what I'm going to do is FOIL the numerator, and I'm also going to FOIL the denominator. When I FOIL the numerator, I get 1 times 1, which is 1, plus radical 3, plus another radical 3, plus whole number 3. Radical 3 times radical 3 is radical 9, which is 3, which is going to simplify to 4 plus, and I have 2 different radical 3's. That's my numerator. And I need to do the denominator also. So when I FOIL that, I get 1 plus radical 3 minus radical 3. Yes, those cancel. And that's what you want. That's the whole purpose of multiplying by the conjugate, is that those middle terms cancel out in the denominator. And 1 minus 3 is negative 2 in the denominator. And last but not least, we can heart method this thing and reduce both of those fractions. Okay, so the way I'm going to write my final answer is negative 2 minus 1 radical 3. Okay, so that was by doing the heart method, and that's just using the tangent formula from above. The tangent formula for addition I used right here. Okay, let me show you another one. This one is kind of split up, and the question is, can you recognize which formula this is? So if this is my A, this is my B. I know this is one of my sine formulas, and because the sign here is minus, it's going to stay that way for the formula. This is the exact formula for sine of A minus B. And so that means I'm doing sine of the 40 is the A and the 160 is the B, which is sine of negative 120. Okay, so now to reinforce some of those negative angle formulas that we already have in this chapter, you guys know that this is the same thing as negative sine of 120. And so I'm going to think about 120 degrees. That's in quadrant 2. The reference angle is 60 because it's 60 degrees away from 180. So the sine is radical 3 over 2, but keep this negative sign in front. And that is my final answer. I want to show you an alternate way to look at this problem, because maybe when you got to here, you were thinking negative 120 degrees is the same thing as, I'm going to write this off to the side. Can you figure out the positive angle that this is by adding 360? It's the same thing as sine of 240 degrees. So it's in the same location. If you go backwards 120 degrees, it's the same thing as going forwards 240 degrees. That's in quadrant 3, and it's still a 60-degree reference angle, and that y value is still radical 3 over 2. So no matter how you think about it, if you use like the negative angle formula that we've been using this chapter, you get this answer. If you got the negative angle and turned it into a positive one, you still got the same answer. I want the same answer, you guys, but you'll start to notice and recognize that some things that we learned in previous chapters are still coming into play in this chapter. Okay, so the next section, it's the same type of thing. We don't have two angle measures. We have one angle and one weird theta thing, but that's okay. I'm still just going to apply those formulas from above and just see what happens. So this is a sine of addition of two angles, and so that means I'm going to do sine of A times cosine of B, which is theta, plus cosine of A times sine of B, which is theta. So I'm just leaving thetas instead of these like degree measures. That's okay. I can still simplify this a little bit. The sine of 30 degrees in the unit circle, that's 1/2. And cosine of theta doesn't simplify to anything because I don't know what the theta is. But cosine of 30 degrees is radical 3 over 2. And the sine of theta is just sine of theta. And I can't combine those. They're not like terms. There's nothing else I can do here. So my answer is just 1/2 cosine theta plus radical 3 over 2 sine theta. And that is as simplified as you can get. That's just using the formula again from the blue box above. Okay. Let's go to the next one over here. It's a tangent one. So again, I'm going to use the tangent formula here. So that means tangent of 45 minus tangent of theta, all divided by 1 plus tan 45 times tan theta. So this is, again, just using the formula. Remember, whatever the symbol is for tangent stays in the numerator and the denominator switches. Tangent of 45 is just 1. And tangent of theta I can't simplify because I don't know what theta is. And then in the numerator, remember, this is also just 1 right here. In the denominator, I mean, so that doesn't really do anything. It's 1 times tangent theta, so I still have my 1 in front and the plus sign and tangent theta. And again, that is as simplified as I can get. Those don't cancel. They're not opposites or anything like that. That is as simple as I can get. And then this last one, similarly, I'm going to use the sine formula for addition. So that would be sine of 180 times cosine of theta plus cosine of 180 times sine of theta. And I can simplify the sine of 180 degrees. So the y value at 180 degrees is 0. So yeah, that's going to wipe out that entire first term. But the cosine of 180 degrees, the x value at 180 is -1. And so 0 times anything is just 0. That entire first term is wiped out. And this -1 times the sine of theta just gives me negative sine theta. And that's all. I am going to save the last section for class tomorrow so we can just do a couple problems together. That is all that I have for you guys tonight. Thank you for watching and have a great evening.